Hello everybody, this example actually is an inclined plane. Just as you see, it's 35 degrees above the horizontal. There is two objects connected via a pulley and a rope together. There's mass A, which is equal to 5.7 kilogram, and mass B, which is 3.2 kilogram, frictionless surface. And these two objects are held together by someone's hand. So this system is kind of like equilibrium because of the force of the hand. Now, what will happen to the system once released? We actually don't know what will happen to the system. So we cannot assume nothing will happen. We cannot do that because this means that acceleration is zero, the system is in equilibrium, but it's actually not a good idea to assume that. So basically, we need to solve this problem as if there was an acceleration. If the acceleration turns out to be zero, then the system is in equilibrium. If the acceleration turns out to be different from zero, then the system basically will collapse either this way or this way, depending on the direction of the acceleration. Okay, how do we go about doing this problem? Well, we have free body diagram we have to start with. So we have this object A. So I'm going to draw it here. So we have that's free body diagram for A. And as we probably learned, this would be MAG sine the angle, which is 35. And going this way is the tension. We don't have to worry about the Y because there's no friction, so for that one. And for B, I'm going to draw it just like that. This is B. And we have tension going above, and here we have what? MBG going down, okay? Now, as you can see, the tension here is the same as tension here. This is considered to be a small pulley that changes just the tension direction without changing its value. So that's why you have one T here and one T here, the same T, okay? All right. Now we have to adapt a system. So going this way, a sine system, going this way is positive. Keep going, keep going, keep going. So basically this would be positive, and going the other way is negative. So going the other way here is negative. Okay, and so forth. Okay, now we are going to assume, for object A, summation over F, all the forces in the x direction must be equal to MAX, okay? And it's not equilibrium, so we have to say maybe it is, we don't know yet, but this is the general form, okay? Okay, so now we're gonna plug in the summation of all the forces acting on object A. T is positive, MAG sine 35 is negative, so I'm gonna say T minus mass of A times G times sine 35 must equal to mass of the object A times the acceleration in the x direction, which is this direction, okay? All right, now I'm just going to plug in some numbers. T minus FA is 5.7, G is times 9.8, and sine 35 is equal to, I'm going to just leave it as sine 35, then I'll do all the calculations again. And that must be equal mass of A, which is 5.7 times A sub x, okay? Now, all of this is, if I do the calculations, T minus 32.04 is equal to 5.7 times AX. Now, as you can see, this is an equation of two unknowns. We can't go any further in it, so I'm going to call this equation number 1. Now for B, remember we said this is the positive side and this is the negative side. So for B, I'm going to say summation over Fy, because it's in the y direction, must equal to mass of B times the acceleration. Now, which acceleration is that? Remember, this whole system is connected together. So if this one is accelerating with an AX, this one is also going to be accelerating with an AX. But this is in the y direction, this is in x direction tilted, of course. So what can we do? Well, Since it's the same acceleration, why do we worry about calling this ax? Okay, so we can just actually take this out, and then we can say, well, let's just call it acceleration. It's just an acceleration. Okay, so I'm gonna just call it A. A is the same thing. That's for object number 1, A, or A, and that's object number B, but they're all connected together. And that's what it is. So I'm going to say here M sub B times G minus T must be equal to MB times the general acceleration. MB is 3.2 times 9.8. Now minus T is equal to 3.2 times the acceleration. Now 3.3 times 9.8 is equal to 31.36 minus T must equal to 3.2 times A. All right, so we can't go any further here. So what do? We are left off with these two equations. I'm going to call this equation number 2. All right, now what do? What should we do? We are solving for the acceleration, remember? So if we are solving for the acceleration, I'm going to just delete this ax, okay? So since we are solving for the acceleration, then we can put this equation maybe in terms of t. So I'm going to take the t here, I'm going to take this here. That's a mathematically sound operation. So I'm going to say 31.36 minus 3.2a is equal to t. I can do that in math. It's just 2 steps in 1 step. Now that's t. Take this nice t here and plug it here. Okay? Because that's our t. And that's what I will do. So I'm going to say here 31.36 minus 3.2a, which is t. And that would be now minus 32.04 is equal to 5.7a. Now, these terms are similar. This one and this one are similar because they have a in them, and this one are just numbers, so they are similar. So I'm going to say 31.36 minus 32.04 is actually equal to 0.69. So this whole thing is 0.69, but with a negative sign. And I'm going to take the minus 3.28 to the other side, so this becomes 5.7a plus 3.2a. 5.7 plus 3 plus 8.9, okay? So minus 0.09 is equal to 8.9a. Now we want a, so divide by 8.9 and divide by 8.9, that goes, and we can find that a is equal to minus 78 meters per second squared. And look, there's a minus sign here. What does that mean? It means that we chose this side to be positive and this side to be negative. So what will happen to the system? It will accelerate. So it's not in equilibrium anymore. It's a very small acceleration, but it's enough to topple this system down, and it's going to go this way because that's the negative side. Okay, that was a good example. Thank you very much. There's a lot of math in it. There's a lot of physics, so it was a good one. Thanks.